Hello everyone. Now we are going to discuss the type of antagonist. And what was antagonist? It was a ligand that has an affinity, meaning that it can bind to the receptor, but it doesn't have intrinsic activity, meaning that after it binds to the receptor, it doesn't elicit an activity or an effect on the cell. And its pharmacological action comes from preventing the action of the real agonist on the receptor. Alright, we can classify the antagonist into competitive antagonist and non-competitive antagonist. Competitive antagonist is the antagonist that could be displaced from the receptor by increasing the concentration or the dose of the agonist. That means that there is a competition between antagonist and agonist. For example, if we have a drug that is beta blocker, a drug that blocks beta 1 receptor on the heart, and this antagonist is competitive, that means that this antagonist competes with the agonist of beta 1 receptor, which is adrenaline, on beta 1 receptor. And if I increased the concentration of adrenaline, adrenaline displaces beta blocker from the receptor and it acts on the receptor. So this antagonist is competitive type of antagonist. But how can an antagonist be non-competitive? This could be through two ways. First, if the antagonist binds to the receptor in an irreversible way, meaning that it forms an irreversible bond with the site to which the agonist binds. So that means increasing the dose of the agonist can displace the antagonist because this receptor is no more functional. The antagonist made an irreversible bond with it. This receptor would work again when the body synthesizes new receptor. An example for a non-competitive irreversible antagonist is a drug called phenoxybenzamine. This drug is an antagonist for the alpha receptor. It is alpha blocker. This phenoxybenzamine binds to alpha receptor in an irreversible manner, and by that way it blocks or it prevents the action of the real agonist of alpha receptor, which is norepinephrine. But it causes that in irreversible way. So increasing the concentration of norepinephrine, which is the agonist of alpha receptor, wouldn't displace this phenoxybenzamine. And alpha receptor is functional again when the body synthesizes new receptor. Okay? Alright. Now another way for an antagonist to be non-competitive is by being an allosteric antagonist. What does allosteric mean? The part allo in the word means another. So that means that our antagonist binds to site other than the active site. This is the active site of the receptor to which the agonist binds. Our antagonist doesn't bind here. If our antagonist bind here in reversible way, it would be competitive. So our antagonist binds here in a site other than the active site to which the agonist binds. And when our antagonist binds here, it causes a conformational change. It changes the shape of the receptor. So it somehow closes that active site to which the agonist binds. So in that way, it prevents the binding of the agonist to its receptor. And so it would prevent its action. So increase the agonist or the dose of the agonist as much as you want. Its site is closed due to the binding of the antagonist to the allosteric site. Okay, so non-competitive antagonist could be an irreversible antagonist as phenoxybenzamine, or it can be allosteric antagonist. Okay, now let's draw a dose response curve as we studied before. This is the curve of a drug. An agonist increasing the dose would increase the response until we get a plateau, or we reach what we called the Emax. Okay, what was the dose at which we reach half the Emax? This is called EC50. Okay, now this is our drug which is an agonist alone. What if we give a competitive antagonist to the receptor to which this drug binds? We give a competitive antagonist, so our receptor now is blocked by this competitive antagonist. And then we would give again this agonist, this drug. We would give it again. A question now. Would we want or we would require the same dose to elicit this same response? For sure, no. Our receptor is blocked. And in order to elicit the same effect, we would want more dose. More dose to replace or displace the antagonist which is competitive, so it could be displaced, but we would more dose to reach the same effect we see here. So if we want to draw this curve of that drug or this agonist after giving the competitive antagonist, we would get the curve here. It is shifted to the right. Why? Because we needed larger dose. The dose here is larger than the dose here to elicit the same effect. Let's take a look at the EC50 of the drug after giving the competitive antagonist. EC50 became more because we needed higher dose to elicit the same response here. So this is the curve of the drug alone, and this is the curve of the drug with competitive antagonist, or after we give a competitive antagonist. Okay? Now, what would be the curve if we gave the drug after giving a non-competitive antagonist? We wouldn't expect to need a higher dose because non-competitive antagonist wouldn't be displeased, but also we wouldn't expect to get the same effect. So we would see a curve like that. That was right shift with the competitive antagonist, but with non-competitive antagonist we almost needed the same dose, but we get a lower response because we couldn't displace the antagonist because it is non-competitive. So our agonist worked on another receptors, giving a response that is lower than the normal response because some receptors are blocked. And this shift is called downward shift. So the competitive antagonist causes right shift while non-competitive antagonist causes downward shift. That was first type of antagonist, which is we call pharmacological antagonist. So pharmacological antagonist could be classified into competitive and non-competitive antagonists.